need to verify internal API tokens without the complexity of public key infrastructure. You'll see how to set up symmetric key verification in FastMCP using just a shared secret, perfect for microservices that need lightweight but secure token validation. We'll configure the JWTVerifier with HMAC signing, ensuring only trusted services can authenticate while keeping the setup simple. From FastMCP, import FastMCP. From FastMCP, server, auth, providers, JWT import JWTVerifier. Hash use a shared secret for symmetric key verification. Verifier equals JWTVerifier. Public key equals your shared secret key minimum 32 chars. Hash despite the name. This accepts symmetric secrets. Issuer equals internal auth service. Audience equals MCP internal API. Algorithm equals HS256 hash or HS384, HS512 for stronger security. MCP equals FastMCP. Name equals internal API. Auth equals verifier. This demonstrates the token verification pattern for distributed authentication, where a service validates tokens issued by an external authority rather than handling user credentials directly. The approach follows the resource server model from OAuth, where your application focuses on validating portable identity proofs instead of managing authentication flows. What makes this distinctive is the complete separation between token issuance, handled by an auth service, and token validation, handled by your MCP server. The pattern works by treating tokens as self-contained authorization artifacts that carry all necessary claims. Your server validates cryptographic signatures to ensure token integrity, checks issuer and audience claims to confirm intended usage, and extracts authorization information without needing to contact the issuing service for every request. This creates a stateless, scalable security model where validation happens locally using public keys or shared secrets, while the issuing service maintains full control over token generation and revocation. This approach solves the challenge of secure service-to-service communication in microservices architectures, eliminating the need to replicate user databases or implement custom auth protocols. It's particularly valuable for internal APIs, where you control both the token issuer and consumer services, or when integrating with existing identity providers. The trade-off is that token revocation requires either short expiration times or an introspection endpoint, but the performance and simplicity benefits often outweigh these considerations in distributed systems. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tool systems. It handles the bridge between your Python functions and AI models, managing serialization, validation, and execution. From FastMCP, server, auth, providers, JWT import JWTVerifier. This imports JWTVerifier, the JWT authentication provider for FastMCP. It handles token validation, ensuring only properly signed requests access your API endpoints. Hash use a shared secret for symmetric key verification. Verifier equals JWTVerifier. This instantiates a JWTVerifier for symmetric key authentication. It validates incoming tokens using a shared secret, ensuring only trusted services can access your MCP endpoints. Symmetric verification is simpler than public-private key pairs, but requires secure secret distribution. Public key equals your shared secret key minimum 32 chars. Hash despite the name. This accepts symmetric secrets. This parameter accepts a symmetric secret for HMAC-based JWT verification, despite the misleading public key name. The minimum 32-character requirement ensures cryptographic strength for HS-256, preventing trivial brute force attacks.
Issuer equals internal auth service.
The issuer claim identifies the authentication service that generated the JWT. This prevents token spoofing by ensuring only tokens from the trusted internal auth service are accepted and forcing a chain of trust between services.
Audience equals MCP internal API.
The audience parameter enforces token validation against a specific intended recipient. This prevents token replay attacks where a JWT meant for one service gets used against another, even if the issuer and signature are valid. Standard JWT security practice for service-to-service authentication.
Algorithm equals HS-256 hash or HS-384, HS-512 for stronger security.
Specifies the HMAC-SHA algorithm for JWT signature verification. HS-256 uses 256-bit keys, while HS-384 and HS-512 offer stronger 384-bit and 512-bit security, respectively. Choose based on your security requirements versus performance trade-offs. This closing parenthesis finalizes the JWTVerifier configuration. It locks in the symmetric key, issuer, audience, and algorithm settings, creating an immutable verifier instance for FastMCP's authentication layer.
MCP equals FastMCP. Name equals internal API. Auth equals verifier.
This instantiates the FastMCP server with JWT authentication enforced. The name parameter identifies this service instance, while auth equals verifier locks down all endpoints to require valid JWT tokens using the symmetric key and claims we configured earlier. This is the standard initialization pattern for secured FastMCP services. FastMCP JWT authentication. The symmetric key pattern shown here balances simplicity and security for internal systems, using shared secrets with HMAC algorithms to validate tokens without complex key management. Never store the shared secret in version control or logs, even temporarily during development. This approach excels when both the token issuer and MCP server are controlled by the same organization.
The secret that must never be seen becomes the foundation of all trust.